at me anymore, right? Go ahead and go in. So our app, if you notice, in order to simply launch our app, we're having to launch at least 4 different microservices. So the reason for that is scalability. Is you want to make sure that when you have, when you're featured on Reddit, whatever it may be, your site doesn't crash, and you can customize how you spin up your instances.
Can you go ahead and tell us a little bit about how the tech works or what it's actually run under?
So I'm about to go over everything that it's run under to make sure you understand our full stack. So the core of our stack is Node.js, where we use Meteor to have the entire bundling system happen. That's how we actually deliver information to our client. Then we use a system called RabbitMQ, which is a messaging platform. And RabbitMQ sends our data via broker into Python as well as Scala to run our actual machine learning and transmit it back and forth. So what we're doing is on our MongoDB client-side facing app, we're inserting and deleting directly into MongoDB. Then at the same time, we're doing the exact same transaction on Python, on Scala, and then we're also, when we do the inserts into MongoDB, we're factoring in data from Cassandra, TitanDB, our other data stores. So we have crawlers that are actually constantly crawling information from Rate Beer and Beer Advocate to better understand what are the similar beers, what do customers want, what are the price points theoretically supposed to be. So if you can go ahead and look up here, our site, I guess one of the first things I can go ahead and demonstrate is just its sheer speed in terms of search. So let's go ahead and do something, because this is how customers really like to look at their beers. Like this thing just it's almost too fast, frankly. So here we can just, this gives you a generally good idea of how fast our site can add stuff to cart. Oh, wow, I'm not signed in. Okay, so let's go ahead and jump to the sign up process. Okay. So Yusuf, what I'll do is just to jump you right in, let's check out the beer club. Oh shit, I accidentally logged out. Okay, so here we go. These questions right now are subject to change. We're still testing it out, so you just have to pick one region. Hey, give us some information. So I'm on the West Coast. Why would I want West Coast beers? Midwest, okay. Let's see something. All right, let's go ahead. Light. These we're going to be adding a lot more to, but we're trying not to overwhelm the client during the initial onboarding process. Let me go ahead and subscribe to it. To give you an example of one of the places we use machine learning, it would be right here. So as you can see, I didn't sub that out, yeah. So as you can see right here, this is $100 a box. This has a 10% discount. This has a 15% discount for 12 shipments, right? The idea is, what is the lowest discount I need to push as many people into 12 shipments as possible? So the other fact is, hey, maybe it's not just a percent. If I made this green and a different number, would they be more likely to convert? The fact is, most people are able to do A/B testing. We're able to do multivariate testing. So that's another reason why your typical craft beer company would not be able to do that versus we can. good old Stripe to process our transactions. Okay, so I've made everything manual, so you can go ahead and see how we're running this. So normally, this message is going to be sent via broker. So these are just 6 random items. What we want to do now is run our actual machine learning script to figure out, if you excuse me, let me just load it up. Okay, so these are 6 random items, right? I haven't done anything. I have my preferences. I have the items I've looked at. I have my inventory, which I'll show you in my dashboard for a second. So there's certain items that aren't moving based on chatter that I'm detecting. There's certain items that are very high in demand. So I will now show you as we run our machine learning script. These 6 beers should go ahead and change in front of you.
Got it.
So as you can see here, we went ahead and tested a few different variants. We inserted it. Let's go ahead and watch for the automatic update, which is again now part of our technology. So I have these 6 beers. I can now, if I do nothing, they're going to go ahead and ship to me automatically. I can also do things like pause my shipment, reschedule it, or change my tier, all of those things. So for these purposes, I'm just going to go ahead and keep or discard 3 and 3. Well, let's make it 3 and 3. Go ahead. So I can keep the item. If I do nothing, I also get it. If I dislike it, we go ahead and tag that there's what are the uncommon similarities based on all the tags we've mined that made you dislike it. What are the most common positive similarities? And then we go ahead and inject a new version in there. So I will also go ahead and show that now. So you can take a look at our admin dashboard. Here's our admin dashboard. Still water, fire, so you see these are the same people. I'm going to go ahead now and apply the next machine learning script based on all of the current movement of inventory. Okay, so this is really the crux of all the different calculations that we're running to get this information. If we look here, this just populated. And based on the amount paid, shipping all of these, we're actually going to make a $33 profit. And if you see, the reason behind that is I disliked this beer. That was $26.99. So this is where the machine learning really comes into play, right? The beer box is optimized for a customer's lifetime value. Each customer has a different lifetime value, and each customer values the beers differently. That is why it seems almost like overkill, right? That we're using a $30,000 server cluster to crunch this data. But the fact is, we are able to maximize customer happiness and maximize retention through an algorithm. If you look closely here, we're able to retrain our algorithm. We're able to tell it, hey, next time, wow, this box, no, that was not the right price. Oh, it weighs too much. The desirability is too high. Let me remove and edit unique keys. Once all of that good stuff is done, if I verify it, okay, let me go ahead and send this poor guy his box. So he'll go over here, and then let's see if he has any other items currently waiting. Okay. Ooh. Look here, we can also go ahead and merge an existing order that he has with his beer box in order to save money on shipping. But I'm not going to do that. I'm just going to go ahead and pack his box, and then I'm going to ship it out to him now. So here he is. Now he gives me a different set of detailed rating preferences that, again, I can now crunch more data with. So if you want, let's just take a quick look at our site one more time and just see, wow, how fast is it to add different items from different people? It's pretty crazy fast, frankly. Oh, here are similar beers. Well, just to teach you guys a little bit something about this, in a general e-commerce site, let's say I have a really popular item and I rank that item nice and high and people love this item and its brand, right? Well, the fact is the similar items on that page are usually more likely to have an add to cart action performed on it. So I should probably, in my most popular similar beers pages, embed inventory that's a combination of both not moving and a suitable match to always keep inventory flowing through the system. So if we go as a consumer, I can take a look at an individual brewery's page. Again, do all my nice sorting, check out the reviews, their followers, all of that activity. One of the other items we're planning on showcasing is the ability to go through all our users. So here, if I can just show you this. Okay, this is one user's profile that you should be able to access to. Here's what he's looking at. Oh, here's what he's following. I can just add this to my cart, to my order right now too. Wow, let me look at some of the other beers he's taken a look at. Oh, wow, he got this in his beer club membership. Let me sign up right now. That's a general high overview of our site. One of the other things I just wanted to touch briefly on, another example of how we fundamentally use technology, is our marketing engine. Right? We found that MailChimp was not suitable to our needs in the sense that I am not going to sit here and automatically run these A/B testings among demographics that I have no information for. So we've actually built in Scala our own app to say, okay, let's first get the email address of the guy, which you can buy from these paid sources, right? But these are very expensive, $1, $2 an email. So what's the first thing I should do? I should mine automatically as much data as I can get. What's on his GitHub? What's on his LinkedIn? What's on his Facebook? Get baseline information. Okay, so now I should have probably his occupation, his demographic, his age, geographical location. Okay, a software engineer who works at Uber, he's probably going to get out at about 3 p.m. on Friday. Let me go ahead and send those guys a craft beer. Hey, why don't you buy on a Friday? And in general, you're a software engineer, you have more expensive tastes. Let me send you a more premium product. If that doesn't work, or if I'm uncertain of my conclusion, let me go ahead and split test it automatically the next time. And instead of doing a 50-50 split, if I think more likely the solution isn't working, let me modify it to 80-20, see if the numbers still match up. These are very important things, I believe, in this new day and age where customer acquisition cost is everything. You live, breathe, and die by your numbers, which is really what we're about.
Okay. Sounds great.
All right, so we'll cut it